let's get into some arithmetic operations. Now, this part right up here is basically just showing you that if it's written like this or like this, it is the exact same thing. It's just two different ways to write it. So same with subtraction, multiplication, and division. They're all the same. It's just two different ways to write the same thing. So let's apply that to example 2. I personally don't like it when they write it this way. I would prefer to write it like this, because then I can just find what f of -1 is and then add it to g of -1. That makes a lot more sense to me. So I have f of -1. Remember, anytime we have something on the inside, we do our big fat parentheses anywhere there's an x and plug in what we're plugging in. Simplify this. -1 squared is 1. 6 times 1 is just 6. And then plus 2 is 8. And so f of -1 is going to be 8. And now I find g of -1. So that is my big fat parentheses anywhere I have an x. Plug in -1. So I get 3 minus 1 over -1 would be 3 plus 1, or 4. Plug that for g of -1. And I get 8 plus 4 is 12. So, there we go. With that basic understanding, I would like you to pause the video and try 2b. So this one's just multiplying. So we have f of 2 times g of 2. So find out what f of 2 is and what g of 2 is, and then plug them in here and multiply. Pause the video when you're ready and try it out. Let's see how you did. So, for f of 2, I plugged everything in, I got 20. For g of 2, plugged everything in, I got 2.5. Plugged those into my multiplying, and I ended up with 50. Let's move on to example 3. Here we've got a subtraction, and notice we no longer have a number, it's just x. But it's still the same thing. We still want to do g of x minus f of x. But in this case, instead of plugging a number into the g equation, I want to take the whole g equation, which is 3 minus 1 over x, and I want to subtract the whole f equation, which is 6x squared minus 2x. Now, be careful right here. Anytime you subtract, you should put parentheses so that you remember to distribute the negative. Otherwise, you'll probably forget to distribute that negative. That's a very common mistake that I see here. So I have the g of x equation minus the f of x equation. Now I can just simplify. 3 minus 1 over x minus 6x squared plus 2x. There we go. And it says to list what the domain is. So remember, domain, I check for two things. I check for even roots, and I check for denominators. Don't have any roots in this problem, however, I do have a denominator, so I say that denominator cannot be 0. No need to really solve, it's already solved. So we know that our domain is everything except cannot plug in 0. And there we go. Let's try example 4. This one's a division one. So same thing, I'm going to separate them. I like to write it better that way. And we're just going to plug the equations in. So I have 3 minus 1 over x, that's my g equation, over 6x squared minus 2x. Now, technically this is our equation. However, it's a general rule that we never like to have fractions inside fractions. So we're going to simplify this so that there's only one fraction, not two. The easiest way to do that is to look at the numerator where our second fraction is. Find a common denominator so I can combine it. So I want to times this 3 by x over x, because then I'm going to have that common denominator, and I can just subtract the numerators. So the numerators, I'm going to have 3x minus 1 all over that common denominator of x, all over my 6x squared minus 2x. Now, hopefully you remember keep, switch, flip. Keep, switch, flip says we can keep the numerator, switch to multiplying, and then flip the denominator. So technically this denominator is over a secret 1, so when I flip it, I get that. That's keep, switch, flip. And now I can just multiply across. So this times 1 is just itself. And this times this, I'm just going to leave like, actually, you know what, for now, I'm going to distribute it in. So 6x cubed minus 2x squared. Because then I notice I have a 2x squared in common here that I can take out. So I take a 2x squared out of everything. Remember, when I say take out, I really mean divide. So 6 divided by 2 leaves me with a 3. X cubed divided by x squared leaves me with an x. And 2x squared over 2x squared leaves me with a 1. Now this 3x minus 1 on top and bottom will actually cancel out. This is going to create what we call a hole in the graph, which is something we'll talk about a lot more in chapter 3. But for now, understand that a hole is also something that cannot be included in the domain. So even though this simplifies to this, because both of these were in the denominator at one time, when we go to find the domain, we still need to set both cannot equal 0. Even though this one totally disappears because it cancels out, it's still included in our domain because it was once in the denominator. So that means it still cannot be there. It creates a hole, which I said we'll talk about more later. So if I solve both of these, I get x cannot equal 0. And x cannot equal 1/3. So my domain is negative infinity, is everything except 0 and 1/3. There we go. So that is a little bit more function arithmetic, adding, subtracting, multiplying, and dividing, including some domain on it. In the next video, we're going to talk about this thing called the difference quotient, which is a huge thing in calculus.